So this related rates problem right here, it says the balloon is rising vertically over a point A at a rate of 15 feet per second. Point B is level on the ground with point A and is 30 feet from point A. At what rate is the distance between B and the balloon changing when the balloon is 40 meters high? So the picture that I'm going to draw for this is going to be a triangle. The balloon is up here. It says the balloon is vertically over point A, so I'm going to come down here and label this A. And then level with the balloon over here, this is point B. And then I'm going to go ahead and label this as X, this as Y, for side to side and up and down. And I'm going to label this as H. It says that the balloon is going up at 15 feet per second. So that tells me that dy dt is equal to 15. Remember, y is changing. They ask me about how something is changing when the balloon is 40 feet high. So I'm going to consider at the snapshot, and I think how we've referred to it before, for when y is 40. X is not changing. That B is not moving side to side, so X is just always going to be 30. That's not a snapshot number. And then H is unknown. We don't know what H is. But we do want to know, it does ask, it says, at what rate is the distance between B and the balloon? B and the balloon. So that's this thing. So we're looking for dH dt equals what? That's what we're looking for. That's what they're asking for. First thing I'm going to do is set up Pythag. I see that as the best relationship between the x, the y, and the h. So I know that x squared plus y squared equals h squared. If I take the derivative with respect to t, I'm going to use x prime here, and what I mean by x prime is dx dt. I think in this particular example, it's easier to use primes instead of dt's. For some of the other examples, I think it's good to use v dt or something like that. Anyway, I get 2x x prime, that's power rule, is 2x, and then the x prime is chain rule. Remember, I'm taking the derivative with respect to t. So I get plus 2x x prime plus 2y y prime, and that's dy dt, plus, or is equal to 2h h prime. So the first thing I'm going to notice with this equation is that, well, x is not changing, so that means that x prime right here, this guy, is going to be 0. So this whole term is going to be 0. So that thing's just going to go away. And I'm not going to have to worry about it. That next thing I'm going to notice is that there's 2's everywhere. So I'm going to divide everything by 2 and get that y prime equals h prime. Alright, next thing I'm going to do, I'm going to come over here and look at this triangle. I got 40 and I got 30. Notice 3 times 10, 4 times 10. What's this going to be equal to? 5 times 10. It's a 3, 4, 5 triangle. So h is equal to 50 at my snapshot. Remember, this is a snapshot number, so that makes this a snapshot number since I used this to get that. Alright, so at this point, I know h, so I know this thing. I know that that is 50. I know y, that's 40, and I know dy dt, y prime, is equal to 15. Remember, I'm looking for dh dt, so I can actually plug in. So I get y times y prime gives me 15 times 40 equals 50 times h prime, that's dh dt. I can divide by 10 on both sides, and then I get h prime equals 15 times 4 over 5, which comes out to be, I can cancel this in and make that 15 a 3. So I get 3 times 4, which is 12. So my answer is that dH dt is equal to 12. And then I should include units with all of my related rates problems. I know that it's rising at 15 feet per second. So I know that the units for this, since it's also a length, should be feet per second. That's my answer.